Can you find the area of this square using just the information given above? Welcome back to my channel. Please, this is not drawn to scale. We are asked to find the area of this square if AP is 8 and A to this point, that is the radius of this semicircle, is 5. So first of all, we're going to write out the information that we have that is already given. So we are told that the radius is equal to 5. That means the diameter is equal to 2r, which is equal to 2 times 5, which is equal to 10. So in short, we are going to write the diameter is equal to 10. Okay, so diameter is equal to 10. And we have that AP is 8. AP is equal to 8. Okay, now, where do we even start from? Actually, we are asked to find the area of the square. Let's first of all find out what the formula for area of a square is. So area of a square is equal to length squared. Okay, so if you're able to get the length, then we'll be able to get the answer. All right, now, so we have length squared as the area of this. So everything we are trying to do here is to find the length of this square. Now we can do that in so many ways, and this is the way I think is the easiest and the better way. Okay, now if we join P to B, like this, okay, we form a triangle APB, right? Triangle APB, which is like this. This is A, this is P, this is B. Now this will be 90 degrees. Angle P is equal to 90 degrees. This is 8. Let's call this side that is unknown T. Okay, now we have AB is 10. AB is 10. Now, why do I say that this is 90, that P is 90 degrees? Angle formed in a semicircle, if this is a semicircle, using circle theorem, angle in a semicircle is what? 90 degrees. As long as one side of this angle, this triangle, is the diameter of this circle, okay, which is what we have here, it means that this angle here is 90 degrees. Okay, so that is why P is 90 degrees. Therefore, we can say that we can find T using the Pythagorean theorem. Using Pythagorean theorem, we can say AB squared will be equal to AP squared plus BP squared. So 10 squared will be equal to 8 squared plus T squared. So if this comes here, we have 10 squared, take away 8 squared, is equal to T squared. So this is same thing as 10 plus 8 multiplied by 10 minus 8 is equal to T squared. If this is the first time you are seeing this lovely channel, please hit the subscription button and turn on your notification bell so that you don't miss our videos. We upload our videos as often as possible. Tune in at your convenience. You must see something new for you to watch. Give us a thumbs up if you love what we are doing. Okay, thank you. So moving forward, we have 10 plus 8 is 18. Bracket 10 minus 8 is 2 is equal to T squared. So we have 36 is equal to T squared. Now let's take square root of both sides. So square root of 36 is equal to square root of T squared. This will remove this and we have 6 is equal to T. So we can write here to be 6. Okay, so let's erase this. We are done with the Pythagorean theorem. All right, now we have okay, now there is another triangle that we can see here, triangle ADE, right? Triangle ADE. Now we know that DE is equal to L, which is what? Length of the square. So DE is L. Now if AB is 10, then AE will be what? 10 minus what? L, because EB is also L. So if this place is L, this place is L. So it means that AE will be equal to AP minus EB or BE. So it means that AE will be equal to AB is 10 minus EB is L. All right. Now I'm going to draw this triangle as well, triangle ADE, and I'm going to label it using this as the length. Okay. Don't worry, this is getting better as clear as daylight. So now we have the second triangle. Let me increase it. So this is the second triangle, triangle ADE. This is A, this is D, and this is E. So this is L, right? DE is L, and AE is 10 minus L. 10 minus L. That is our AE. Now, I want you to notice something. E is 90 degrees, right? Because we are told that this is a square. So definitely this is 90 degrees. Therefore, this is 90 degrees. So that's why E is also 90 degrees. Okay. Now, let us compare triangle ABB and triangle ADE. Now, you can see that both triangle APB and AD and triangle ADE are right angled. Both are right angled, or both are right angled triangles. This is the first bullet. Now the second one, you can see that both share angle A. Angle A. You can see that. Okay? Both share the same angle. They both share the same angle A. So using angle theorem, right? Yeah, using angle theorem, AA style or AA theorem, we can say that triangle APB is similar to triangle ADE. So if triangle APB is similar to triangle ADE, then it simply means that the area of the corresponding sides are equal. The ratio of their corresponding sides are equal. So they are similar. Now let's see how we can make use of the ratio to find the unknown sides. Okay, so we're almost at the end of it. So let us see if we can draw the ratios. Okay, bring out the ratios. So if we say DE should be DE over PB, right? Should be equal to AE. AE should be over AP. Yeah. So DE is L, PB is 6, AE is 10 minus L, and AP is 8. So if we cross multiply, we have 8L is equal to 6 brackets 10 minus L. Okay, so we have 8L is equal to 6 times 10 is 60 minus 6 times L is 6L. So let's transfer this minus 6L to the other side. We have 8L plus 6L is equal to 60. 14L is 60. L is 60 over 14. L is 30 over 7. If we divide both sides by 2. Now, are you trying to tell me that we have found the area of the square? Yeah, we have. Because the only obstacle between us finding the area of the square is just the length. And now we have a figure as our length, then we are done, right? So area of the square is length squared, so it should be equal to 30 over 7 squared. 30 over 7 all squared, okay, which will be equal to, now 30 squared is 900 and 7 squared is 49 units squared. Okay, so this is the value. You can press this in your calculator to actually get something in decimal. Thank you so much for watching and see you in my next video. Bye.